Second lecture of internal combustion engine, valve timing diagram, petrol and diesel engine. TDC ignition, exhaust, compression, suction, expansion. BDC, valve timing diagram of four-stroke engine or auto cycle. Top dead center, fuel injection started, inlet opens, fuel injection, exhaust close, fuel injection completed, exhaust opens, inlet close, compression, exhaust, induction, power, suction, compression, power, exhaust, 30 degree duration, 60 degree, 90 degree duration. IVC means inlet valve close, EVO मतलब inlet valve open. Four-stroke petrol engine, first IVO 10 to 20 degree before TDC, second IVC 30 to 40 degree after BDC, third IGN 30 to 20 degree before TDC, fourth EVO 30 to 50 degree before TDC, EVC 10 to 15 degree after TDC. Four-stroke diesel engine, first IVO 10 to 20 degree before TDC, second IVC 20-25 to 40 degree after BDC, third FVO 10 to 15 degree before TDC, fourth FVO 15 to 20 degree after TDC, fifth EVO 39 to 50 degree before TDC, sixth EVC 10 to 15 degree after TDC. Two-stroke petrol engine, first EPO 35 to 50 degree before BDC, second TPO 30 to 40 degree before BDC, third TPC 30 to 40 degree after BDC, fourth EPC 35 to 50 degree after BDC, fifth IGN 15 to 20 degree after before TDC. Two-stroke diesel engine, first EPO 30 to 45 degree before BDC, second TPO 30 to 40 degree before BDC, third TPC 30 to 40 degree after BDC, fourth EPC 35 to 50 degree after BDC, fifth FVO 10 to 15 degree before TDC, sixth FVO 15 to 20 degree after TDC. Valve timing event, TDC and BDC, intake valve open 21 degree before TDC, valve overlap, exhaust valve close 15 degree after TDC, power stroke, intake stroke, exhaust valve open 57 degree BDC, intake valve close 51 degree after BDC, exhaust stroke, compression stroke. Combustion in spark ignition engine, first diesel engine, second gasoline engine, third HCCI engine, homogeneous charge compression ignition. HCCI means homogeneous charge compression ignition. Reducing soot and NOx emission in HCCI and petrol engine, the fuel and air mixed before combustion, preventing the soot emission of diesel engine. Only HCCI engine have multiple ignition point throughout the chamber. This plus their Lean burn keeps temperature low, preventing formation of nitrogen oxide. Diesel engine, petrol engine, and HCCI engine. Ignition point, fuel and air mixture, air. Multiple ignition point, fuel and air mixture. SI spark ignition engine, compression engine, homogeneous charge compression ignition. Start of combustion in three types of engine: gasoline spark ignition, diesel spark ignition, gasoline homogeneous charge compression engine, spark plug and fuel injector. Burning fuel, air mixture, air piston. Burning fuel, burning fuel, air mixture and piston. Stage of combustion in SI engine: crank angle, ignition lag, combustion phenomena in spark ignition engine. In spark ignition engine, homogeneous mixture of air and fuel is formed by the carburetor. Air fuel mixture is compressed up to compression ratio of 8 to 12. Mixture is ignited by spark plug. A turbulent flame is developed which propagates through the charge. Three stage of combustion: ignition lag, it consists of growth and development of propagated flame. It depends on temperature, pressure and nature of fuel. It's also depend on propagation of exhaust gas residue. Second, propagation of flame. In this stage there is sudden rise in pressure and temperature. Velocity of flame is constant. Heat release rate depend on reaction rate of charge. Heat transfer to cylinder wall is low. Third, after burning in this stage highest pressure is reached. Velocity of flame decrease. Combustion rate also decrease. Combustion in spark ignition engine: supercharging. What is supercharging? In this process of increasing the mass or density of air fuel mixture in spark ignition engine or air in compressed ignition engine sucked into the engine cylinder. It is done with the help of compressor or blower called a supercharger. In spark ignition engine, it is mounted before the carburetor, which is reduce the size of carburetor. Effect of supercharging: to maintain power output of an engine working at high altitude where less oxygen is available for combustion, to reduce the space occupied by the engine, to reduce the consumption of lubricating oil, to reduce the mass of engine per bp, to to increase the mechanical and thermal efficiency, to increase the volumetric efficiency. Specific volume, specific fuel consumption is less chance of detonation due to high pressure. Turbocharging. What is turbocharging? In this process in which energy extracted from the exhaust gas by the turbine is utilized to drive a supercharged, that is centrifugal compressor. About 30% of heat goes out through the exhaust gas. It depends on types of engine and operating condition. This gas turbine is directly coupled to the centrifugal compressor. Ad- advantage of Advantages of turbocharger: reduce pollution from exhaust gas, reduce fuel consumption, reduction in power loss due to decrease in air density at higher altitude, increase power output of engine, more power to weight ratio, better torque characteristics. Detonation in IC engine, knocking or pinking. What is detonation? The loud pulsating noise heard within the cylinder engine due to auto ignition of unburnt fuel. High pressure valves are created. These high pressure waves may break the piston. Combustion process top view. Combustion chamber side view. Firing end temperature heat range. Short heat flow path, short nose length, long heat flow path, long nose length. Cold plug, medium, hot plug. Heat rating number. Factor for detonation, the shape of combustion chamber, relative position of spark plug, chemical nature of fuel, initial temperature and pressure of fuel. Effect of detonation. Noise due to detonation, sound intensity increase pre-ignition due to overheating of spark plug. Increase heat transfer due to high temperature, increase heat transfer. Mechanical damage, high pressure shock wave may damage piston. Decrease in power output due to abnormal combustion, decrease power output. Remedies or detonation is controlled by increasing in engine's RPM, retarding sparks, reducing pressure in inlet manifold. We will cover in next chapter turn a moment diagram.